Namaste to all my dear students. How are you? Today I am going to give you very important Friedel-Craft reaction and what we see octane number and cetane numbers. They are very important for knowledge as well as what we see examination. So what we see at first, we have to know Friedel-Craft. Friedel-Craft reactions. So that is very important for examination as well as what to say examination viewpoint. So that is Friedel and that is the Craft. So two chemists who gave this reaction. So that is very important. So what the principle of this reaction is to convert aromatic compound, for example benzene. Its molecular formula is MF is C6H6 into alkyl or acyl benzene. Yes, so very important reaction to convert hydroaromatic compounds. For example, benzene, its molecular formula is C6H6 into alkyl or acyl benzene. Yes, so at first, what you see A so what you see alkylation reaction. Yes, so what it means? Alkyl means insertion or substitution of alkyl group, you can say alkyl group in benzene ring in presence of Lewis acid catalyst. For example, maybe aluminum trihalide, maybe what you see boron trihalide, maybe iron trihalide, where X is maybe chlorine, maybe bromine, maybe iodine. So in short, when we talk about the alkylation reaction, means insertion or substitution of alkyl group in benzene ring in presence of Lewis acid catalyst is known as alkylation reaction. So it's very simple reaction. So what do you see over here? So at first we have to know the what is the structure of the benzene. That is H, that is H. That is known as benzene ring. Yes. So when that is treated with RX, RX means alkyl halide. Yes, RX halide in presence of what's a Lewis AlX3. Yes, so what you get, that H react with this X. So that H is substituted by R. It has negative charge, it has positive charge. So that is nucleophile, that is electrophile. So what type of substitution over here? Electrophilic. So what you see? Electrophilic substitution reaction, and what you get? That is the benzene ring. H is substituted by R, and what you get? HCl. H hydrogen, H X. Yes. So that is alkyl, that is known as alkyl benzene. So what you see over here? That H of the benzene is substituted by this R group. So what type of reaction it is? Electrophilic substitution reaction. That is the general reaction, you can say. General reaction, you can say. For example, that is the general reaction. For example, when we take, that is the benzene ring. So in all carbon, that all is carbon, 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 carbon. How many carbon? 6 carbon over here. So what you see? So all are carbon, H, 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 H. So when that is treated with suppose CH3, what the name of this compound? Chloromethane. In person, always you have to think over here. If chlorine, then what we have to use? Aluminum chloride. If bromine, what we have to use? Aluminum bromide. If iodine, what we used? What we see? Aluminum iodide. So what we have to use? AlCl3 catalyst. That is also known as Lewis. Lewis, name of the chemist, Lewis catalyst. And what do you get? So H positive electrophile, that is a nucleophile. That H reacts with this chlorine. So what we have? CH3 plus HCl. So what the name of this compound? Methyl benzene. What the name? Methyl benzene. If suppose H CH3 CH2 Br. So what we have? Bromo ethane. So when that is treated with what Lewis acid we have to use over here? AlBr3, not Cl. If Br, Br. If Cl, Cl. So very important. Always you have to consider. So what we have? Again, so that has what you see positive charge, that has negative charge. That H is substituted by ethyl group. So what we have? Catalyst. So what do we get? C2. So what we get? CH2, better to write, CH2, CH3 plus HBr. So what the name? This compound is known as ethyl, what to say? Ethyl benzene. If what is propyl, then what we have? Propyl. If butyl, what we have? Butyl. So we can prepare any halogen compound. What is the alkyl compound? So that is very important reaction to convert aromatic hydrocarbon into what you see? Alkyl benzene. Yes. So that is alkylation reaction. Next one is AB, acylation reaction. So, how can you define? So, insertion or substitution of RCO group, that is known as acyl group, better to say, in benzene ring in presence of Lewis acid catalyst. So, what do you get? Acyl benzene is obtained. Yes. So, always in presence of Lewis catalyst. If not catalyst, so this reaction does not take place. So, what we have? So, that is what is general reaction. We can say RCO, what is X? Better to say X plus, that is the benzene ring. Yes, again what we have? So, X negative charge, it has positive charge, it has negative charge, that is, you know, nucleophile, that is electrophile. So, what do you see again? That X substituted by this acyl group in presence of what you see? AlX3 catalyst. So, what compound you get over here? COR plus what do you get? HX. That is known as acetobenzene. What is acyl benzene? You can say that is known as acyl benzene. Yes. So, that is the general reaction. So, you can use any acyl. Acyl means RCO, that is known as acyl. So, always keep in mind that is known as acyl, that is halogen group, you know. So, example is like this. For example, look at over here, that is the benzene. So, when that is treated with CH3COCl in presence of aluminum chloride catalyst. So, what do you see again? So, it has positive charge, it has negative, that is what you see? Nucleophile. So, that H is substituted by this acyl group. What the name of this compound? The name of this compound is what you see? Ethanoyl chloride. Yes. So, what product you get over here? CO CH3 plus what you see? HCl. So, what the name of this compound? Acetophenone. Very interesting example. So, what you see? Sometimes ask you question. Question is like this. What is Friedel-Craft reaction give suitable example. One question. Second, how to convert benzene into A, methyl benzene, B, aceto. So I have already given you from benzene to what to say acetophenol. You can do this one, acetophenol. I have already told you what to say alkylation. So what you get? Methyl benzene. Very simple question. So sometimes ask you what is Friedel-Craft reaction. Sometimes ask you how to convert benzene into a methyl benzene and acetophenol. Yes, so you can solve this question, I think. That is about Friedel-Craft reaction. Next one is very simple. What you see? Reaction of phenol into benzene. That is also very important. So when phenol is reacted with zinc dust, we get benzene by reduction process. Yes, so look at reaction, very simple and very important. So what the formula of phenol? That is phenol. We can write what is the phenol, or we can write hydroxy benzene. When that is treated with the zinc dust particle, powder of zinc. So when it is heated, so process is reduction, and after reduction what we get? Removal of oxygen. So that oxygen is removed by this zinc. So what product you get over here? What you get? That is benzene plus what you see? Side product is zinc oxide. That is the zinc oxide. So what the process over here? So that oxygen is removed by zinc. So removal of oxygen is known as reduction. So after reduction what we get? Benzene. So that is very, very important. Sometimes ask you in what happens? Sometimes how do you convert phenol into benzene. So you can convert it easily, I think. So that is about the reaction of phenol. Reaction of phenol with benzene, not phenol with zinc dust. So when phenol is reacted with zinc dust, we get benzene by reduction process. So already what you see? That is the example, and it's very, very important example. And also ask you, so sometimes ask you to convert phenol into benzene. So in this case you have to write the reaction, not necessary what you see language. So when conversion, so only we have to write the reaction, appropriate reagent, and after reagent, after get what we get? Product. Yes, conversion we never write. What you see? Language. So that is about what's the reaction of phenol with zinc. And we have clear what are the Friedel-Craft reaction. Yes. Next one is quality. Quality of gasoline. Gasoline means fuel. Example is maybe petrol, maybe diesel. These all are the hydrocarbon. So quality of gasoline. Gasoline means maybe petrol, maybe diesel. It's fuel you use. Motorcycle you use, car. Yes. So quality of, for this we use quality of gasoline, we use two terms. We use two terms. First one is octane number, and second one is what we say cetane number. But generally what you see octane number is asked in examination. So you use two terms, octane number and cetane number. So first one is octane number. That is very important, and that is used for petrol fuel. That is used for petrol fuel. So what do you see? The quality of fuel means maybe petrol, maybe diesel, is determined by anti-knocking properties. Anti-knocking properties of the fuel, and it is indicated. It is indicated in the form of octane number. So what term is what's anti-knocking. Knocking means when you knock the door, that is knocking. We get some time of what is sound over here. So this knocking sound is what you see we have to reduce, and that is known as anti-knocking properties. You never, if you what is the fuel gives what is the cracking sound and what is the knocking sound, that is not good fuel. If it does not give what you say cracking, does not give cracking sound, so that is the good fuel. Yes. So when we talk about the octane number, it is generally done for petrol fuel. So the quality of fuel is determined by anti-knocking properties of the fuel, and it is indicated in the form of octane number. Then we have to know what is octane number. How can you define octane number? So octane number it is the number which gives percentage composition by volume of, suppose, iso octane in the given mixture of what to say iso octane compound having its octane number is 100. It means it is a standard value. It is a standard value. And N means normal. Heptane compound having octane number is 0, which has same anti-knocking properties as a fuel under consideration. So I think so you have to take the example. So always keep in mind, for as a note, higher the octane number of the fuel petrol, higher the octane number of the fuel, there is good quality of fuel and vice versa. So generally when we use what we see petrol in aeroplanes, generally 100, more than 100. And when you use what you see in motorcycle, what we have? About 70 to 80. Yes, the octane number. So higher the octane number of the fuel, what we see, there is good quality of fuel and vice versa. If you lower the what you see octane number, what you see fuel is very low grade. So quality of the what you see gasoline, or better to say petrol, is determined with the help of what you see octane number. So for this we use a standard compound like what you see CH3, CH2, 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 1, 2, 3, 4, 5, 6, that is N. N means normal heptane. Yes, so its octane number is 0. What you see? 0. Yes. Next one is what's isooctane compound. CH3, 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 CH2, CH3. So what the name of this compound? Common name is iso. Why iso? Because it is branch over here, branch of carbon over here. So what do you see? Isooctane. In what do you see? IUPAC name. 1 position, 2 position, 3 position, 4 position, 5 position. So what do we have? 2, 2, 4. Trimethyl pentane. Its octane number is number is 100. That is also the standard value. What do you mean by standard value? Like when you talk about the what to say atomic mass of any carbon, oxygen. So always we have to consider with respect to what to say hydrogen or carbon, 1/12 of carbon taken as 12. So what to see? Likewise, in this case, when you determine the octane number of the fuel, so you have to see the percentage of what you see N-heptane and isooctane compound present in the fuel. If what you see 80% isooctane compound and 20% N-heptane, so what the octane number of the fuel? 80. Why? Because the octane number of the isooctane compound is what you see 100. The what is the octane number of what is N-heptane? N means normal. Heptane is 0. So one problem. So what is the problem is like this. Problem 1. If fuel petrol contains what you see 80% isooctane and 20% N-heptane compound by volume. Always we have to see by volume. Find the octane number of the fuel. So in this case, what you get? How much isooctane? 80%. How much what you see N-heptane? 20%. So what the answer of this question? What the answer of this question? Answer of this question: octane number of fuel petrol, you can say better, is 80 because fuel contains 80% isooctane compound by volume. Always you have to mention this one by volumes. So clear. If suppose isooctane compound is 90 and 10% N-heptane, what the octane number of the fuel? 90. If 75% is what you see isooctane and 25% what you see N-heptane, what the octane number of the fuel? What is it? 75. I think you have clear how to find the problem. Yes. Next one is Cetane number. It is generally done for diesel fuel. Yes. It is the number. It is the number which gives. It is the number which gives percentage composition by volume. Cetane in the given mixture. Cetane in the given mixture Cetane, that is also known as N hexa decane hydrocarbon, its molecular formula is C16H34, having cetane number, standard value, cetane number is 100, and what to say, alpha methyl naphthalene compound having cetane number is 0, which has same ignition means burning temperature. Ignition means what you see? Ignition means burning temperature as the fuel under consideration. So look at, for this we take a consistent compound is like CH3, CH214, CH3, or you can say C16H34, that is N hexa decane hydrocarbon. Its cetane number is 100. It has spontaneous ignition. Yes. Next compound is, that is alpha methyl naphthalene compound. Its cetane number is 0. It has slow ignition properties. So what you see, the cetane number of the fuel depends upon the what you see percentage of the hexadecane compound present in the fuel. So suppose we take one problem over here, problem like this. Problem: if fuel diesel, in diesel case what we use, what we say cetane number. So you have clear, diesel contains what is 60% 16% yarn hexa decane compound and 40% alpha methyl naphthalene by volume. Find the cetane number of the fuel. What is the general knowledge? So it contains 60% yarn hexadecane. It means cetane number is 60. If 70, then 70. If 80, then what is 80 cetane number? It depends upon the concentration for the percentage of yarn hexane because its cetane number is 100. And what you see, alpha methyl has 0. Yes. So answer is what you say, cetane number of the fuel is 60% because 60 because it contains 60% yarn hexa decane. I think you have clear. If 80% yarn hexane, 80 cetane number. If 90, then 90. It's general knowledge. Yes, that is the what see octane number and cetane number. Next one number is what you say anti-knocking reagent. Knocking भनेको cracking sound. Knocking means cracking, crack sound we can say. Anti-knocking reagent. Sometimes ask you what is anti-knocking reagent. So those chemical substances which are used to reduce knocking or you can say cracking sound and increase the octane number of the fuel is known as anti-knocking agents. Best example is what you see tail. Tail means tetraethyl lead. Its formula is tetraethyl C2H5 lead Pb. How many ethyl? 4. So tetraethyl lead is known as tail. That is also known as tail. It is used for reducing the what you see knocking sound as well as increasing the octane number of the fuel. So, generally 0.01% tail is used in gasoline. Gasoline means maybe petrol, maybe diesel. Yeah, we can say 1 to 1.5 ml in 1 liter of fuel. So I think you have we have clear what is the what to say anti-knocking substance, what is tail, and how much tail is used in gasoline to reduce the what to say knocking sound, as well as increase the what to say octane number. So question is generally like this. Question: what is octane and cetane number? Give its suitable example. Next question: what is tail? Tail compound. Give its uses. So I think you have clear what is tail. Tail means tetraethyl lead, and what the uses of this to decrease the knocking sound as well as increase the octane number of the fuel. So that is very important for examination. So generally in examination ask you what is octane and cetane number. Give a suitable example. Next question: what is tail compound? Give its use. Or sometimes what is anti-knocking substance? Give its application, or you can say uses. So these are the questions generally asked in examination. So they are very important for what we see knowledge as well as examination viewpoint. So that is why what to say thank you very much for watching this video. I think you have already done subscribe about this video, and also I think you have shared, you have convey your this channel to other friends. Today's okay. Next day I will come with new video.